Okay. Good afternoon, everyone. So I guess that there are no baseball fan in the audience because I guess we're conflicting with the Game 6 of the Brave Padres series. So no baseball fan in the audience? No. Good. Now, before I start, I would like to, they've asked me to make a small announcement. At the end of the session, there'll be a Q&A period, and we would like to record that. So if you have questions, we would like to ask you to walk to one of the two microphones that is set up in the center aisle and ask your question so that it can be recorded. Okay. So what we'll be talking about and exploring in the next hour and a half is security as it relates to COM+. And if there is another focus to this talk other than security, I like to think that it's simplicity. And I know that this would draw a chuckle from some people because usually security and simplicity are not supposed to mix terribly well. Security perhaps has a well-deserved reputation for being complicated, hard to set up. It's typically the last thing that you do, and when you try to do it, it breaks your application. But what I would like to show you is that with the right perspective, with the right way of squinting at the problem, it's possible, in fact, to turn it around and to reconcile those two apparently, hard to reconcile notions, that is security and simplicity. And so the agenda of the talk pretty much reflects this. So it will start first by a short review of the COM+ security architecture. And what I would like to focus in that review is precisely this sort of empowering perspective on security, how to look at security so that in fact you can structure the problem in such a way that its complexity can be dealt with in a satisfactory fashion. And after that review, this will sort of naturally flow into the issue of then, well, how do you use this ID and the COM+ security architecture, which is centered around that ID. And we'll see that the paradigm there is to sort of leverage the environment by using a configuration paradigm so that you configure, first of all, the lowest level security service, namely authentication, okay, so that you have a sound platform on which to build security. That as much as possible, you configure access control, which is what your application really cares about. And then, through the exploration of some three-tier scenarios, we will also take a look at the few programming idioms that you need to master in order to be able to build elaborate scenarios. Okay. So first, I would like to take a second to explore the question of what security is about, because as some of you probably have, if you take a look at a lot of security books out there, you'll find that inevitably the first chapter is devoted to cryptography, right? Then perhaps the second and third chapter have to do with the low-level authentication protocol, and they show you how to do Kerberos and key exchange, key distribution protocols, non-repudiation, and sort of a very low-level view of security. Now, what I would like to do in this talk is try to turn this around a little bit, and instead of looking at security from the bottom, working toward the application, I would like to take an application view of security. And from the application, security is not about encryption. It's not about Kerberos and key distribution. What security is really about is who can do what to what. It's really that simple, okay? And so know that it's essentially about access. Okay. Now, that can be broken down into first an issue of policy, which has to do in the specification of who can do what to what. And then coupled with the policy, you have an enforcement mechanism, which is there to ensure that the policy that you specify is in fact enforced. Okay. So now let's explore this in the next level of detail here. So we have a policy, which again simply states who can do what. And here we have a little who, something that they're trying to do, and you have the thing that they're trying to do it too. Okay? Now, the typical architecture of an access control service, also known as an authorization service, is typically to stick a sort of a guard at the door that takes a look at the requests that are being made on the resource that it protects and decides, according to the policy, whether or not to allow the request to proceed. Now, just let me introduce a teeny bit of vocabulary here. In the security community, the who is typically referred to as a principal. It's simply a subject, a user from a security standpoint. The what is simply a request, of course. The guard is sometimes referred to as a reference monitor, and the what are the resources that you're protecting. Okay. Now, so now we have the policy, and we have a sort of a very, very high level architecture on a mechanism that can support access control, which is really what, from the application standpoint, security is about. Okay, controlling access to the resources that application offer. Controlling who can do what. But there is, a question that, that needs, to be addressed before you can do authorization. And that is namely the following question. Now, it's all well and fine to put a very nice authorization system into place. For example, you have a receptionist at a building and security person and guarding the entrance. And, he's got perhaps a list of the people who are authorized to access the building, and somebody comes in and they authorize them, according to the list that he has. But this authorization decision that he has to make is only meaningful if the information that he has about the people who present themselves at the entrance of the building is reliable, right? Okay, and that's known as the problem of authentication. So in order to be able to build this higher layer of security, namely access control authorization, you need to make sure that all the system elements that authorization deals with are authenticated. Okay, and that's the problem of authentication. So for example, from the reference monitor standpoint, from the guy standing at the door standpoint, certainly there are some questions about the legitimacy of the person showing up, and asking to enter the building. Okay, so the job of the authentication service is going to be able to say, yeah, the claim of identity made by that principal trying to do this action is in fact true. Okay, now similarly, in some situations, it's important for the subject, the principal trying to perform some sort of operation, to they can have legitimate question as to the authenticity of the resource that they're trying to access, or the person guarding this resource. So it's sort of a two-way street there. So the job of the authentication service is also to make sure that those are authentic. Now finally, when in the typical computing environment, when you have this sort of a subject and the reference monitor engaging in interaction, there is of course also the question of the authenticity of the request. Imagine, for example, the situation over the network. So I have a client, I have a server, the client calls the server. How do I know as a server that the request that I'm getting is in fact authentic? So authenticity also has scope in terms of the authenticity of the communication between subjects and resources. Okay. So again, the main idea here is that we're building up this sort of architecture, this layered system, and at the bottom we have this authentication service that essentially enables the authorization service. Okay. Now let's take a look at what this all looks like from the application perspective. Okay, so from the application standpoint now, the view of security is that you're an application, you express an access control policy, an authorization service enforces the policy that you specify, and that authorization is itself enabled by an authentication service, which makes sure that all the system elements are in fact authentic, so that the authorization decision that you make are in fact meaningful. So now, what's very, very interesting to notice here is that when you structure the system this way, is that the application only interacts with the authorization service. Okay, and that from the application perspective, the authentication is transparent. It just happens. It's a property of the environment. Now, if this model looks familiar as I think it should, it's for a good reason, right? Think about programming in a standalone operating system. Okay? Well, in a standalone operating system, certainly, as an application writer, you don't have any concern about authenticity of the code that you're calling, let's say if you make a library call, and vice versa, a service, a local service, certainly doesn't have any concern about the authenticity of the identity that is presented by a particular client. Why? Because you've got the operating system which locally makes all those guarantees, creates those environment invariant essentially, okay? And so the idea here is that we're going to see how in COM+ we try to recreate this in a distributed environment, of course with the help of the operating system as we'll see, etc. But that's the basic idea, to sort of recover this paradise lost in a distributed system, where the application can only deal with authorization issue and not have to worry so much about authentication. Okay, so now let's take a look about how those concepts map to COM+. So first, let's draw a brief outline of how COM+ authorization works. Okay, so you've got a policy, again, who can do what. Now, in this case, the sort of the requester is, a COM+ client. So now, in terms of its identity, this identity comes from NT, and it's embodied in something called an NT access token. Okay. And in the rest of the presentation, what I've done, I represent this as a little rounded rectangle of various color to represent the different identities. Okay. Now, the request in the COM+ context is, of course, a method call. Okay. And the resources that you're protecting are components, their interfaces, and methods. Okay. Now, those are grouped in a COM+ application, which, as we will see, can also have an identity of its own. And then, as the reference monitor, we have the COM+ executive, essentially, the library, the surrogate, etc., that enforce the policy, which is expressed using a paradigm called roles, and we'll discuss roles in quite a bit of detail later on in the presentation. Now, note that in order to make the access control decision, typically you're going to need to, of course, know what is the client identity. So that is why you see here represented the little access token or something corresponding to the access token of the client that is essentially matched up against the security policy as the who, so that you can make the access decision. Okay. So the COM+ authorization model is sort of three-pronged. The first prong is what I just showed you. So it's you can configure access to methods in a completely automatic way using roles, and it's enforced automatically for you by the COM+ executive. Okay. It's also possible for applications which have private resources to protect, resources that the system itself cannot possibly know about because they're intimately tied to the application semantic. So it's possible for an application essentially to programmatically avail itself of the role policy and use it in order to secure access to private application resources. And finally, we also support the traditional NT-style security, whereby a component needs to act as if it were the client, okay, in an access model known as impersonation. And we'll see some of that later as well. Okay, so to recapitulate here for a second, so the application controls access with roles. Okay, it is done on the one hand using configuration to protect method call that is done completely automatically, programmatically to protect private application resources, and finally there is also an impersonation style access control so that you can access resources on the client's behalf. Okay. Now let's take a look at authentication. Now I brought back here the picture of the authorization model because remember, authentication is simply there to enable authorization. And when you look at it, you see that there are a number of elements here that requires authentication by the system. In particular, we're going to need to authenticate the client identity, so that it can be used when you make the access check, so that it can be used when you do impersonation style security. Now also the client may want to authenticate the server as well. And finally, we're going to need to authenticate the method call. Okay. So the first thing to note is that the user identity of the client and the COM+ application come from the directory service. So CompLus is, in that sense, leverage completely DNT security services. So, okay, so those identities are defined in the directory service. Now, because a role policy has to do about who can do what to what, you can expect, of course, that when we define what roles are and when we see how they're used, they will use themselves identity and group, which are also defined in the directory service. Now, once the client and the CompLus application start interacting, then there is the entire question of security on the wire. So now what needs to be happening in order to, in fact, authenticate the client, authenticate the application, and make sure that all the use of the client identity, for example, in authorization decision is meaningful. And for that, we rest on DCOM, which is itself is built on top of authenticated RPC, which in turn rests on a variety of security service providers, such as Kerberos, NCLM, SSL. And these provide authentication of the client, authentication of the server, and again here notice as well the authentication of the client identity in its use for access control and impersonation. And finally, once there is a conversation established between the client and the application, it provides for authentication of the method calls themselves. Okay. So the idea here is that with respect to the authentication, we will have a configuration model whereby we let DCOM and Windows NT transparently do the authentication work. So that's very, very important. That is transparent from the application perspective. And we do that so that the focus of the application can be where it belongs, and that is at the authorization level. Okay. Okay. So first, I would like to turn to authentication and talk about authentication configuration issues, how authentication works, etc. And then, once we have built this sort of platform, we'll be able to move to the authorization issue with our minds free of those sort of low-level considerations. So, in terms of configuration, there are several things that need to happen in order for authentication to work. One of them is that you need to establish a trust path between the client and the server. Okay. Now, what this means, in a sort of to use an analogy, it's a sort of the following idea. When a client presents itself to a server, for example, it will typically present some sort of a credential or an identity card of sorts, right? Which contains a claim of identity. Now, in order for the server to sort of be able to use this to authenticate the client, it needs essentially to have trust in the authority that is vouching for the credential that is being presented, right? So, for example, well, I know this has happened to me, but I know that if you're in Massachusetts, for example, and you try to buy some liquor, they ask you for an identity card, and they don't accept out-of-state license. Okay, so in that case, there is no trust path between the licensing authority, let's say, in Washington State, and the Massachusetts, liquor laws or whatever. On the other end, if I present myself with my Belgian passport at a border crossing, let's say in another country, in the U.S., for example, I can gain admittance here, and my passport is seen as a legitimate representation of my identity, essentially because there is an implicit trust between, I guess, the American government and the Belgian government, that in fact those credentials properly represent my identity. Okay, so we need to build a similar kind of relationship between the client and the server in some way, so that authentication can occur. You also need to configure the server identity, and we'll see that is in particular, it becomes important when we take a look at the three-tier scenario. And finally, the client and the server also have to make some sort of statement about the quality of service, the degree of protection for the method calls, for the information that is being exchanged between the client and the CompLus application. And this, we'll see, can be configured per host for clients and per application for CompLus application. Okay. So now, from a CompLus standpoint, in fact, in general, from an NT standpoint, what does client-server trust mean? Well, it either means that the client and the server belong to the same domain, okay? Or it means that there is inter-domain trust between the client and the server domain. Now, there is also some, at this point, still, limited, but getting better handling of non-domain situation, where you cannot, create a direct trust relationship, and you can do that with non-domain clients which have public key certificate. And the way that you can do that, you can use DNT, certificate mapping facility, whereby you can take client certificate and map them into domain user identity. So this comes in particularly handy when you deal with internet scenarios, and you can do that fairly easily with the Internet Information Server and Site Server. And you'll be able to do this directly with DCOM once we support SSL. We're working hard to try to have it for NT5, the DCOM support of SSL. Otherwise, we'll just have it a little later. But so those are the three main ways of establishing this client-server trust. Okay. Now, in terms of authentication level, here are the various levels that are possible. First of all, of course, you can have no authentication. Now, if you have no authentication, you can have no meaningful authorization, and you have no security. So, we'll not talk about that one very much. You can also have a level which essentially, in fact, the connect and the packet level are in fact distinct level, but in many, pragmatically, they're almost the same. And essentially what this does is that it authenticates the origin of the data that is exchanged between the client and the server. The next level up is integrity, which protects the integrity of the data against modification, let's say in transit. And finally, the highest level is a privacy level, which protects the data against eavesdropping. Now, for COM+, the authentication quality of service, the protection level on a call between a client and a COM+ application is determined as the maximum of the client-specified level and the server-specified level. And note that this provides a handy way in terms of configuration control to control authentication mostly on the server side, right, since it's the maximum of both. Okay. Now, of course, if you could, that's another problem that people sometimes have with security, is that, they turn security on and performance goes down the drain. Okay. So, if we had, like we have in the case of a local operating system, let's say, very good hardware support in, for security. In the case of the local operating system, it's of course memory protection, for example. That's one of the facilities available for security. This would not be an issue, and everybody would always use privacy. But unfortunately, we're not quite there yet. So let me describe to you the sort of the structure of the performance picture in terms of authentication. Now, first of all, there is a connection cost when the client and the server engage into a dialogue that essentially corresponds to establishing one another's identity, and the authenticity of the identity, and also getting essentially something called as a session key, which lets them protect the interaction that they have. And this connection cost is essentially the same constant cost for all levels. So that's the cost that you pay whether you select a low authentication level or a high one. Now, in addition to that, let's also take a look at what is the cost per call for call size n. So the first interesting thing is that in terms of a network cost, the cost on the network in terms of bandwidth utilization are negligible, because it turns out that a good encryption doesn't need to expand data. Okay, so there is just a marginal fixed size header typically cost that is associated in terms of network utilization, and that's it. Now, in terms, so the price that you have to pay in order to do authentication is in fact typically a CPU cost. And first of all, it's a modest order n cost that you pay for integrity. And what this amounts to, essentially, what you're paying for is, first of all, calculating a cryptographic hash of the data that is being sent between the client and the server, essentially a signature of that data, and then encrypting that signature. And then there is a more substantial cost, also order n cost, when you do privacy, because in that case you have to do actual encryption. You have a buffer copies, etc. So that's somewhat more expensive. Now, I resisted putting hard numbers in there. I'm sure some of you would probably have liked to see, because I rather provide a framework to understand where the cost structure is, rather than put numbers which are only meaningful on my particular, installation, or the person who made the test, on that particular Pentium machine with that much memory, with this particular network. So I think that it's probably, better just to give you an idea of where the costs are for those various authentication level. And in a subsequent, we do subsequent testing of this and provide some data points for various configuration, but that's essentially the performance picture. Okay, now once you have a trust path between the client and the server, and once you have configured these authentication levels, etc., what happens? So we've got the client and the server. And let's follow this roughly on a timeline. Now, I will admit that in the following diagram here, I'm glossing over some details, and in particular, the order in which I'm presenting things may not strictly be a reflection of what really happens at the protocol level, but from a logical standpoint, it is fairly true to facts. Okay. So first of all, there is a sort of negotiation in terms of authentication level, again, selected as the maximum between the client and the server. After this is done, there is a negotiation of the authentication protocol to use. As you may remember from my authentication slide, there are several security services that can in fact provide the foundation for DCOM, and in particularly probably for the next couple of years, when there's going to be a lot of interoperability scenario between NT5 machine and NT4 machine, where all the protocols may not be available, we negotiate a protocol and try to pick the best quality protocol available. So in an NT5 only situation, this will boil down to Kerberos. In an NT5 to NT4 situation, this will select NTLM. Then the server authenticates the client. Okay, so now we have the client is authenticated, and just in case you forgot, that's really one of the really important steps of authentication, right? Because remember that the big payoff of authentication is that now that we have an authentic client identity, essentially we can pass it on to the upper layer, to the authorization layer. It's a bona fide client identity, and then the authorization service can make a meaningful access decision. So that's really an important step. Then optionally, the client authenticates the server. This is available with Kerberos only. And finally, once the two are finally engaging into a meaningful conversation from the application standpoint, so the client calls the server, the authentication server protects the method calls. Okay. Okay. So that's it. We're done with authentication, and until the little demo that I have for you later on, this is the last I'll speak of authentication. And again, the main point here is that I've shown you, okay, how to set up a platform, an authentication platform, on which your authorization service can rely, and that insulates the application from having to deal with authentication. Now I would like to move to sort of the meat of the presentation, at least from the application perspective, which is how does one deal with authorization, with access control with COM+. And the way I will do this is as follows. First, I will examine a very elementary client-server scenario, okay? And we'll take a look at the various tasks and ways of controlling access in that scenario. Then we will look at a few three-tier scenarios. And the spirit of this examination will be to try to identify in those scenarios the basic pieces that you need to understand in order to be able to build more elaborate scenarios. Okay, so we're literally going to, we're going to look at the stuff and sort of pull out those little puzzle pieces that should allow you to build, well, I was going to say arbitrarily complex scenario. I will not go quite that far. But rather elaborate scenarios. Okay. Okay. So first, let's take a look at again in more detail in the authorization picture in the simple client-server case. Okay. So again, the three-pronged approach. First of all, you can configure access control to protect method calls. Okay, so that's one way to do it. So in that way, the COM+ executive will automatically check calls against the policy that you've specified using role, and make sure that calls are routed accordingly. Okay. In addition to that, we'll take a look at the way in which an application can protect its private application resources by availing itself of the role policy. And finally, we'll also see that there are some cases where, in fact, it is useful to use a NACL-style access control mechanism, particularly for very fine-grained access control, where you maintain security per object instance and things of that sort. And in that case, there is we'll see how it's possible to, in fact, obtain the access token of the client and use it to perform an access check against an NACL. Okay, so let's take a look at each of these things in turn. Okay, first let's take a look at roles. So we have an application, and the application typically has a bunch of components, and themselves have interfaces, and they have methods. Okay, so what COM+ authorization lets you do is that you can create roles for this particular application, and then think of them right now as a class of authority with respect to the application. So for example, if I have a financial application, you may imagine that you have several level of user authority with respect to this application, such as, for example, one that a manager may have, one that a general manager has, one that a clerk has, perhaps a customer. So essentially, this represents the application view of its own security. Then what you can do, you can take those roles and you can assign them to the various application widgets. So for example, I can assign it here to a component. And when I assign it to a component, what I'm declaring, I'm saying everything under this component can be accessed by, in this case, the red role. Okay. You can also assign roles at the interface level, in which case, again, you're saying the scope of authority for the yellow role here is all the methods that are member of that interface. And then finally, you have access also to the lowest level of granularity, which is that of the method, and you can assign a role directly to a method. Now, so we've got sort of the application side done now. Now, what happens on the other side? What's, to complete the picture here? So we've got a client who's trying to make a method call. And now, the issue here is how do we map or establish a relationship between the client identity and the role, okay, or perhaps a collection of roles. And the way we do that, we do this through the directory service. Now, as you remember, the identity of the client is in fact a bona fide, NT identity coming from the directory service, okay. Now, what we typically do, we map those identity into groups which are also in the directory service. Now, in NT5, what is really nice is that you have a very, very rich group structure because you can nest group within one another, so you can model very complex organizational relationships. So you can do the group thing quite a few times, and eventually you map groups into roles. And this effectively creates the role membership of the client with respect to that application. So I would like to point out here, of course, is that a client can have many different roles depending on the application that the client accesses. Now let's see what happens when the method call is made. So for example, let's say that you're trying to access the stop method level here. Now, the method is within the scope of a yellow role, so the access check passes and you can access the method. On the other hand, if you try to make access to this method there, that is not within the scope of the yellow role, COM+ will fail that call. So that's pretty much all there is to roles. So you see, not terribly complicated. And again, that level of protection, that level of access control, you can get automatically. You have to do absolutely nothing from the application standpoint, with the caveat, of course, that authentication has to be in place. And I will repeat this a couple of times, for the balance of my talk, and I'll apologize in advance if this starts to sound boring. But okay, now in terms of application using roles in order to protect private resources, there is a little bit of programming to do, but it's quite straightforward. What you do, you use essentially a built-in object called a security call context. And the way to think about the security call context is essentially as a bag of information, of security information regarding the call that is being made onto you. And then you use this call context in order to discover the role membership of your caller, and then you simply act according to the result. Very, very straightforward. Now, in addition to that, there is also an admin SDK so that you can, in fact, do role configuration from, programmatically. Okay. Now, the third prong, which is sort of the ACL access check, again, you'll want to do this typically in an application which requires very fine-grained authorization. Now, I don't know whether you code that, but when I showed you the way role work, I showed that you assign role to classes, to interfaces, to method, as opposed to per instance. So if you need per instance security, roles are not the perfect match. And sometimes, per instance security is good. So a prime example of that is a file system, right? The NT file system, for example, NTFS, has ACL protecting every file. And there it makes sense to protect resources individually. So for that case, you may want to do, the regular NT ACL style security. And so in order to do that, you need to obtain the client token, which is essentially the embodiment of the identity that you will use to check against the ACL. And I personally feel that the way that we do that is a little roundabout, because instead of having I guess a code that lets you get the token right away, even though I guess you could write a little veneer that would do that very easily, you have to impersonate the client, and we'll talk about that a little more. In order to be able, so the result of impersonating the client means that simply the access token of the client is put on your thread, essentially. Then you grab the access token from the thread, you revert to yourself, and then you use the token that you've obtained in your access check against some security descriptor, essentially an ACL, that the application maintains. And then you act according to the result. So again, same sort of paradigm, somewhat different technique with a slightly different scope of applicability. Okay, now those were sort of server-side tasks, right? Now, what do you need to do on the base client in that very simple client-server scenario? Well, you don't need to do anything. The caveat, again, though, is that authorization depends on authentication, so you need to make sure that there is a trust path between the client and the server. You need to worry about properly configure the authentication level so that, again, authorization is meaningful. But that's it. That's all you need to do on the client. Okay. Now, before we move on to 3-tier, I would like just to show you, try to make these things a little more concrete. Let me just show you a little bit what this looks like. Okay. So laptop. 1, 2. Okay. So as most of you seen perhaps the admin talk, the CompLus admin talk that was given earlier today? Yes? Can I have a brief show of hand there? Okay. So I'll assume that you've seen it already. So I will gloss over that and just show you what I'm here to discuss. So here I have an application called this and that, because really it's a little grab bag. And again, here the point is not to show you so much, a full-fledged application, but that just to show you an application where I can demonstrate all those security idioms that I said I would describe for you earlier. Okay. So you see the this and that application. Let me first show you here in the property page for that application, the security relevant part. First of all, you've got a security property page, which first of all describes the minimum authentication level from the server point of view. You've got something called the impersonation level that we'll talk about a little later. Then you've got here saying, use the CompLus role-based security and enable role checks. Okay. Then we see that for this application, I've defined 3 roles. I've defined a clerk role, and then an employee role and a manager role. And each of these roles is populated with a particular user group. And in fact, you could put more than one if you wanted. In this case, there is only one per role, but that's there is no limitation there. Okay, and so you can see that there is an empty group that is mapped into those roles. And then the roles themselves are bound to the particular application widget. So for example, here, if you look at the dat method, you can put its property pages, and you look at the security page here, and you'll see that the role that applies to the this method is no, to the dat method, I guess, is that of a manager. Yeah. Huh. Interesting. Now at the component level, in fact, this came. If you look at the properties here, you can also assign them to components. You see that the security here is enabled at the component level, and you have the same sort of assignment of role at that level. Okay. So once again, let me show you this again. So these properties. Okay. So now notice that the this method can be accessed by manager. That's because the manager has access to the entire component, and by clerks. Okay. On the other hand, note that the dat component, as we just saw, can only be accessed by managers. Okay. Now, let me just show you how those rows, how those groups, in fact, are populated. And I'll just bring up here the console here. So if I look at the groups here, if I look at, one second, power user guest, bank teller. So, for example, the branch manager, which, the bank teller, opla. So the bank, oh no, sorry about that. Bank tellers, all bank tellers, yes, has my identity in them. So I'm a member of bank teller, but that's the only group that I'm a member of with respect to that application. So let's see what this means, when you try to use the application. So here I've got a little application, and so this button simply will call the this method, which does nothing but return a little string. So I try to call it, and you see this works. Okay. Now if I try the dat method, on the other hand, this fails. This is failed by com automatically, and you see, access permission denied. And in fact, if we went, no, I'll show you that later, but you'll see that in fact all the application failure are logged against the application log. So if we went to the event log now, we could see that in fact there is an access failure for my identity trying to access this particular method. Okay. Now for the rest of the application we discuss when we move on to 3-tier scenarios. Okay. So let me go back. Now, of course, in many realistic and useful cases involve more than simply client-server relationship. And typically, as part of processing a particular request, a component will have itself to call other component. And so the question becomes, what do you do with security in those cases? Now, I will discuss 3 different approaches, and again, from each of these approaches, we'll try to extract sort of the puzzle pieces, the idioms that are required in order to build more elaborate scenarios. So the first way of handling security in this case is to make the access check upfront. So the first component that deals with the client performs an access check against the client identity, and then when it accesses other services, other components, it accesses them as itself. I don't know whether the color shows up as distinct enough, but you can see that the color on this call is in fact the one corresponding to the application identity. Okay, so that's one way of doing things. And because in that case, you have essentially this component here essentially trusts the component that is fronting it to make the proper access decision. We call this type of scenario the trusted server scenario. Okay, so again, you perform the security up front, and then calls are made under the server identity. At the other end of the spectrum, you can have a completely different model where essentially the component projects the identity of the client forward in its interaction with other components. Okay, so and in this case, you make the access control on the back end. Okay, and this is we call the impersonation delegation model essentially, because the client acts as if it were the the server acts as if it were the client. Okay. Now, the problem, if we only had those two approaches, is that, we find out that they are useful in some cases, and we'll identify, the scenario when these idioms are useful. But the problem is that, they seem, in fact, to leave a big space in the middle. And the reason for that is that, well, in the trusted server case, you lose a lot of information, right, between the client and the backend server, because the only thing that comes through in terms of security is the identity of the server. Okay. In this other scenario, we see that one of the problems with that scenario is that performance becomes a real issue and scalability becomes a real issue. And the reason that it becomes a real issue is that essentially, there is a cost in each of those calls here when you authenticate them. There is essentially an authentication cost. There is also a cost related to whether or not you can do things such as pooling, etc. And when you project the client identity, essentially you defeat all the efficiency that you can derive from sharing as you can with the trusted server. So there is a problem there. So what I would like to discuss as a third case is a sort of the important three-tier case where the backend is a database, and in particular is SQL Server 7. And what we can do in this case, we can leverage the fact that both CompTIA and SQL Server use the notion of roles, okay, which in some sense can be thought of as a sort of as an identity that is local to an application. And what we're going to do in this case, we're going to make an access check in the middle tier, and then we're going to project the role toward the database, so that in the database you can perform an access check, now not on the basis of the user identity, but on the basis of role membership, which is not quite the same, but it's still quite useful. And what this will let you do is to avail yourself of a richer access control model on the back end. Okay. So now let's discuss those three scenarios in turns. And before we do that, we have to again talk a little bit about access policy and go back all the way to the top of the talk when I talked about, hey, what is security about? It's about who can do what. It's about access. Now, let's examine different types of access control policy. So you could have one type of access policy, in fact, it's the one that we have on the system application in CompTIA, is a policy which says that an administrator can do everything, and everyone else can only have read access to the resource that I'm dealing with. Another type of policy is where you say that, okay, someone who's a manager can perform operation up to a particular threshold, while someone who's a clerk can only perform them to this other threshold. And finally, you can have another type of policy, which is that a manager can only access a report's personnel data. Okay, so that you cannot find a salary of somebody in a completely different area of the organization. Now, when you analyze those policies with some, a little closely here, what you'll notice is that they seem to have sort of a two-dimension. One of them talks about the subject, the who's doing the access, and the other one speaks more of the data, right? So now let's take a look at those policies in turn again and try sort of to classify according to the level with which they're more subject policy or data policy. So when you have a policy that says an administrator can do everything and everyone else can only read, this mostly speaks about subject. So it's very much centered on who's doing the whatever, right? And only minimally about what they're trying to do. In this next policy here, it's still mostly about the who, but now because you have those thresholds, it is a little more about what they're trying to do. And then in this final policy here, there is really an intricate relationship between the subject who's trying to do the access and the data that she's trying to access. So in this case, definitely the policy requires quite a bit of knowledge about the data. Okay? Now let's see how the various three-tier schemes, machinery, design, map to those policies. So first, let's take at the trusted server case. Well, the trusted server case is really best suited when you need to be enforcing a policy type that are very much subject-centered. And the reason for that is relatively clear, right? It's because on the middle tier, well, the client is calling you. You have access to the who very easily, right? He's calling you. You know the who. On the other end, you may not really know what it is that they're trying to do. You know, they're going to a database, perhaps multi-tier of component. If you need to find out, it's going to cost. Okay? So the trusted server model is, again, best suited for the policy type that are subject-centered. The very nice thing about it is that it's very efficient. And the reason it's very efficient, again, from the security standpoint, is that all the connection from the server to the backend are the same. So you can do things such as connection pooling. There is no authentication needed on every call. You just authenticate once, right? So it is very efficient. Now, in terms of what needs to be done in order to effect a scenario of this type, there is very little that needs to be done. And in fact, the only programming task that is required is that one of the things that you've got to deal with is that even though it may be well suited to your policy type to do the access up front, you still need to know sometime on the back end on whose behalf a particular operation is being made. And this is particularly true for auditing, for example. So we provide a facility whereby you can get the identity of the base client, not so much to do access control, because again, the access control is done here up front, but simply in order to find out the identity so that you can log an audit event, for example. So the scenario goes like this. The client calls in, there is a check made by the middle server, and then the middle server makes a call as itself, and then the backend server gets the base client identity for audit. So how is this done? Again, we're using the security call context. And there is a, here I'm showing this from Visual Basic perhaps to emphasize the sort of simplicity aspect. You know, you don't have to be a C programmer to access those features. And this essentially is a property collection. So one of them is called original caller, and a sub-property of that is the account name, and that's how you find out. And then you would here add code to record an audit event. Okay. Now, the security call context, in fact, is somewhat more general than simply being able to inquire about the base caller. In fact, it lets you discover information across nested COM plus calls. So the scenario goes a little bit like this. So here you have a base client and a number of applications that are called in turn. So, you know, the call is initially made. The server here builds up this call context and passes it on to the next component, which passes in turn to the next one, etc. Okay. So what is contained in this call context is essentially the identity of all the upstream caller, plus some information about the actual security, the authentication that took place between any two of them, such as the authentication service that was used, what level was used, etc. Now, it's a good foundation for auditing, but note the caveat that it's only as trustworthy as a direct caller, because you'll know that we pass this call context as data. So it's not really a part of the authentication service per se, right? The authentication service is used to build it, but once you pass it on as data. But again, this will work well in trusted server scenario by definition, because in fact, you know, all the server all the application in your server tier trust one another. In fact, what you see a lot of people do when they build such application today or using other systems is that they simply pass the user information as data, literally. What we're providing here, if you want a convenience facility where you don't need to add it to every single of your method signature. Okay, so let's now take a look at this sort of trusted server with the SQL Server model, where again the main idea here is that we're going to try to improve things a little by conveying roles to the database, the role membership of the user to the database, so that you can do richer access control in the database. And this really is suitable for most access control policy type, because in reality, there are only very, very few cases where you absolutely need to have the user identity for access control. In fact, when you think about the reason for that, it's really a scalability reason. If you have a lot of resources, you have resources distributed all over the place, and if your security policy, okay, describes for each of those resources access based on user, whenever your user population changes, you have a nightmare configuration problem, because you've got to go traverse all the space of resources that you have, modifying access control. So I mean, typically, you don't really need to do that anyway. And in order to do that, it leverages a new feature in SQL Server 7, which are called application roles. And the way to think about application role essentially are as a database-specific identity. And here I mean database, not database server. So in other words, you can create a database in SQL Server 7, and within that database, you can create roles. And roles function as a little identity that essentially clients who code in that database are able to activate, to function within that role. Okay, so that's sort of the basic idea. And what we do in this case, we make a call, perhaps we perform some sort of check, from a component standpoint. Then we discover the role membership of our caller, and the application needs to establish a mapping policy between the COM+ role and the SQL role. Then you activate the role in the database using a store procedure, and then essentially you thereby convey this role membership to the SQL server, who can perform its own check against the data. Okay. So what is required on the middle server? Well, you need to discover the caller role membership, as I just said. You need to establish an application policy. Again, it depends what your application does, and that will be required in order to map, again, the COM+ role onto the database role. It will also be useful when you have users which are a member of multiple roles, and you perhaps need to prioritize, what is the authority that is proper, in those cases. And again, you use the store procedure setup role to activate the database role. Now, a little note here. Note that once you set a role on a database connection, it applies for the lifetime of the connection to the database. So for that reason, you probably would want to use object pooling in order to make sure that this is efficient. Okay, so we would essentially create pools of objects for each role in the database and use those appropriately. Okay. Now, on the database side, what you need to do, first of all, you need to restrict access to the database to the trusted server identity. That middle tier of server, you need to make sure that you restrict the access to the database just to those trusted server. And the reason that you need to do that is that in order to activate a role, this identity in the database, you need two things. First of all, you need to specify what role name you want to activate, and then you also need to specify a password in order to activate the role. Okay. Now, unfortunately, password management is a big pain. Okay. So, in other words, if I'm in the application, I'm in my application server, and I need to make a call to that store procedure, and I need to provide the password, I need to worry about where am I going to store this password, what am I going to do to maintain consistency between the password in the database and in my application. I need to develop perhaps a UI so that you can manage it. It's not very nice. So what you can do is that if you restrict access to the database to only the trusted server, they will be the only one who can activate those roles. And because they're the only one who can activate those roles, and you trust them, you don't need to use a password. Okay. Now, caveat there is that it is still true in this case that the database audit will be performed under the server identity. So there, in terms of audit, we don't really help you there. And one workaround would be to do the audit on the server tier, using the call context to discover the caller identity. We keep on working on this until we have everything just right. That is still one area that is somewhat lacking. Okay, now let's finally move to the last three-tier model, which is the impersonation delegation model. And there again, its main use is when you have a very heavily data-centered policy. And again, I made the argument just a second ago that I don't believe that such policy really exists, but perhaps if you had a very strict audit policy that absolutely required the actual username, that would be true there. And perhaps in some exotic case where you absolutely need the user identity, those may also be applicable. Note that it requires a Kerberos protocol, because as we'll see, in the general case, it involves delegation, which is only supported using Kerberos. And note also, though, that fortunately, it is automatically selected by CompLOS if it's possible. So again, you don't have to really worry about that. Now, the main drawback of this way of doing this three-tier scenario is performance. And in particular, note that you have 2 authentication per call. Okay, 1 here between the client and the first tier, a second one between the middle tier and the back end. It can be expensive because you can have late access failure, right? You're doing most of the checking there in the back end, so a call can go fairly far and be fairly expensive in terms of resource consumption before it fails. And also it defeats connection pooling, because essentially, you need databases and authenticate at connection time. And so once you've established an identity for a particular connection, that's it. It's there for the lifetime of the connection, and you cannot reuse it for another client. Okay. So in terms of the tasks that are required, here for the first time we see a bit of a client task, and I'll explain what this is about. Well, the main point is that if a client is going to allow a server to act as itself, essentially it's lending its identity. Now it's very important that the client be able to control to what extent it is willing to lend its identity. Okay? So that's why there is a little bit of work here on the client side. So the call is made. Then the middle tier server needs to do a little bit of work to impersonate the client. In fact, I mean, they're very simple call, as you'll see. Then do work as a client. So the result of doing the impersonation is essentially to get the access token of the client on the thread. And from then on, all the activity that you perform on that thread will be made in the security context of the client. So now when I make the call to the backend server, I make it as the client, and the check is applied against the client identity. Okay. So again, from the client perspective, the main task here is to make sure that we're controlling the use of our identity, and we do that through the use of something called impersonation level. So here I've got my little client, and you see that it's important here to talk about machine boundaries. So here I've drawn a machine boundary. So the first, well, in fact, there is one level I don't talk about. There is a possibility of making a call at an impersonation level called anonymous, and then you guessed it, I guess, at that level, the server cannot discover anything about the identity of the client. That's one level that I omitted from the slide. Then the next one up from there is the identify level. And when you make a call at identify level, the server can obtain your access token, and it can be used to make access checks. So for example, you can perform role checks with that. You can perform ACL check. But if you try to make a call under that identity, the call will fail. Okay. Now, the most powerful level is a delegate level. And when the client specifies the delegate impersonation level, what this means is that the component that you call can obtain the client identity, and then it can use it to make any sort of call it wants. Okay. And then in the middle, you've got something called the impersonate level, and here it's useful to distinguish between the case where the component is local to the machine and the case where it's remote. Okay. So if you make a local call, then the component is able to obtain the client identity and to make calls under that identity, local calls or remote calls. But if you make a remote call to a remote component, it can obtain the identity, it can make local call, but if it tries to make another network call, that call will fail. So it sort of bounds the scope of the identity that the client lends to the server to one network hop. Okay. Oh yeah. So here is my the one hardcore API slide that I have here. where I'm going to describe to you the API that is required on the, that's used on the client side in order to change its delegation level. And in fact, you'll see it's a little embarrassing because I think there are 8 parameters to this API and we only use 1. But it will be also a good opportunity perhaps for me to show you what it is that you're missing or in fact not missing in terms of all the control that if you wanted you could have on COM security. Okay, so first of all, in that code you have to specify essentially the interface on which you're setting security. Okay. Then you can specify the authentication service that you would like to use. Again, let COM decide for you. It will pick Kerberos if it's possible, otherwise it will use NTLM. So here we'll just use a default. Okay. You can pick an authorization service. Now, as far as I know, I think this is completely ignored. I think it's simply there for a legacy DCE reason because RPC, on which we are built, supports it, but we don't use it. I don't believe we use it. So anyway, use the default there as well. Now, from the client perspective, remember that it's also possible to authenticate the server. So this is the place where the client would specify, hey, I'm making this call, and I think I should be talking to that guy making this call. But again, we provide in the activation machinery a way that bootstrap this, and you can also specify a default. So if the machine is configured properly, that can occur safely. Okay. You can specify an authentication level. Again, I've argued fairly vehemently and repeatedly that that should be simply configured. So here, simply use again the default that was configured. And now finally, we're getting to the impersonation level. And in this case, we want to bump it up to delegate. So we're going to do that. And we say we need we would like to allow the server to use our identity. There is also another parameter here which is called the authentication info, which essentially lets you supply explicit credential. So for example, you can specify a name and password, and the call will be made in the security context of the user that you're specifying. Now, in my opinion, this was mostly useful in NT4, and the reason it was useful in NT4 is that, as I described in a minute, there was a bit of a problem with COM impersonation behavior. And so that was one way to work around that problem. And it's also perhaps, in some, okay, 15 minutes. It's also useful in some rare cases where you need to, perhaps you need to do a manager override, so you have a clerk is performing some sort of operation, and for one part of the operation it requires manager authority, so the manager comes in, types in his password or something of that sort. And even then, I believe that you could handle those scenarios without having recourse to this. So anyway, you can specify null here. Then finally, there is a capability flag, which to some extent affects some more exotic aspect of the security behavior. The only one of note is cloaking. I will discuss that in a second. The default works just fine. Now, so that was on the client side. All that simply to change that one, the impersonation level. Now, in terms of the what happens in the middle tier, so the only thing that we're going to need to do there is simply impersonate the client. So one thing to note is that in order for this to work, the server identity needs to be marked as trusted for delegation in the directory service. And this is a really nice little touch that DNT folks added to the directory service, which is a way essentially to let you specify who are the user, the principal, the services in your enterprise, which can be delegates, okay? And the reason that is nice is that it gives you sort of a peace of mind that if by accident, perhaps a client that was not programmed with enough care ends up delegating credentials, that those credentials in fact cannot be used unless administratively in the directory service this attribute has been set on the application identity. Now, in order to perform work as a client, very simple, you simply need to make 2 calls that don't take any parameter. First of all, you impersonate the client. The result of this is simply to take the access token of the client and put it on the thread, so that all calls from that thread will be performed in the security context of the client. Then you do some work as a client. And then once you're done, you simply revert to the server own identity. Okay. Now, for those of you in the know, you may be asking yourself, well, what about cloaking? I mean, last year when we gave this presentation, I didn't give it, but when the person, of the COM team, gave this presentation last year, I mean, we made a fairly big fuss about cloaking, and well, I'm not sure. Well, and I think it was a little fuzzy in most people's minds. So let me give you my take on cloaking, and I think it simplifies thinking about it a great deal. What happened until NT5 is that if you made a call to co-impersonate client, and you put an access token on your thread, and you were, for example, to make an access to a file, okay? So you make an access to a file. You would expect that call to be made in the security context of the client, and indeed that's what happens. Okay. On the other hand, until NT4, if you were to make a method call to a component, what identity comes along? Ouch, the application identity. Okay. So essentially, cloaking fixes this behavior. When you enable cloaking, the call that is made here is made under the impersonated identity. And so, in other words, it reconciles COM impersonation behavior with the rest of NT. We enable it automatically for you in complex application when we initialize them, when we initialize the surrogate, so you don't even need to worry about that. And you can simply now have the confidence that when you impersonate in a complex application, COM calls will work as every other call to any system resource works. So all the call will be made in the security context of the client. Okay, so now time for, do I still have how much time do I have left? 10 minutes, okay, 10 more. So let me now show you a little demonstration of the various techniques that I just covered. And what I will do here, so in fact, let me show you the disk component here. So here I'm showing you the text. It's all written in Visual Basic of the this and that application I showed you, a component I showed you a little earlier. And you remember the that method which simply returned that, the this method which simply returned this. Then there are a couple of more elaborate things. One of them is a function that is that transfers some money, okay? And so the work here done within this method is simply to get the call context. You check whether the amount of the transfer is over the manager limit, is over the clerk limit. You make sure that that the policy is enforced, using the role check here. And then, if the operation is allowed, you in fact create another object in another application, which is called a bank application, and you deposit, you do some work, you withdraw some money from somewhere. It doesn't show you, this doesn't show you how you do that, but that's not the point. And then you deposit money into another account, and then you relay the transfer information back to the client. Okay. Now on the so on the backend server, the deposit method is really elementary. It's simply call the security context. It obtains, using the call context, the original caller name, and then it sends back a message, reporting that the deposit was initiated by such and such user. Okay. Now, let's just take a look at how this is configured in terms of security. So if you look at let's look at the Explorer here. Let me collapse some of this. First of all, let's look at the bank application, the component here, and the roles. Now note that there is a single role, and the role is trusted server. And there is a single group in that trusted server, namely the trusted server group. And just to show you that I'm not cheating here, that trusted server group has the following identity: server 1, server 2, server 3. That's it. Those are the only identities that are in that role. Okay? So, and you can see that that role is the only, well, of course, if you look at here the security page here, It's the one role that is assigned to that component. So anyway, the net effect is that it's only server 1, server 2, server 3, my trusted server are the only one who can access the bank application. Okay? Now, let me go back to the demo here. So now what I'm going to do, I'm going to transfer some amount of money here. So I transfer the money. And notice that the call, in fact, goes through. Okay? So, in fact, the bank component returns information that it recorded a deposit. It correctly said it was deposited by me. And, in fact, again, to show you that I'm not cheating, you can see here that, in fact, I'm logged on as that user. So this is all true. So the deposit was initiated by the client. So it has recorded in terms of audit, if you want, the client identity. Yet the call must surely have been made as a server identity, right? Because I showed you that those were the only identity that had access to that component. I didn't have access to the component. So that is a trusted server scenario. And in fact, let me just show you very quickly one more thing here. No, not this one here, but rather this one. When I talk about the client identity, the application identity, so we're making the call through the this and that application. One thing I didn't show you is that in the property page, there is this identity page where you can define what identity the application runs under, and that's where this comes from. So, you know, the client identity called the this and that application, which was running under that identity, which made the access to the bank account object. Okay, so that's one scenario. Now, in the other scenario, let's take a look at, I have a human resource or a make-believe component, which essentially access some sort of a private human resource information for a particular employee. And the policy that we're enforcing here is that only a human resource representative can inquire about personal information that is not their own. So in other words, everybody else can access their own information, and only human resource personnel is allowed access to information that is not their own. So that's the check that I'm actually performing here. So if first I get the user identity using the object call context, then if that identity is different than the employee for whom the information is requested, then it must be true that the caller is an HR representative. And if I'm allowed, if this is allowed, then I return information. Otherwise, I report an error. Okay. Now let's very quickly take a look at the way this is configured. Let's take a look at the HR. Sorry. So in terms of roles, we have employee, HR, and others. So in the employee role, I've got all employees, and M. Levy is a member of that. In the HR group, we have just the HR team. And I will skip the others right now. But anyway, those are the the role we want to focus on. So now let's see what happens on the in the this and that application here when we look at there is a user info method, and what the user info method it essentially collects information about a particular user, and among this information it collects HR information. Okay, so you gather some information. Then you create a, you impersonate, you know that you impersonate the client, so you're going to do all this work as a client. You know, you create the HR object, you grab the info, and then you relay the information back to the client, reverting to to your own identity before you do that. So now let's see what happens from the front end. So, oh yes, sorry. In order to be completely emphatic about the previous case, I had here a button that tries to directly access the bank application. I told you that this was not possible, and in fact, if you do that, you see that in fact the permission is denied. So I'm sorry, I forgot to demonstrate that. So you see that it's not possible. In other words, the only way that you can access this information is in fact through the trusted server. Now, in terms of the user information, so what's going to happen when I make this call? The this and that impersonate me and makes the access to the human resource component as myself. And so in this case, I'm requesting information for myself, so that should work. And in fact, yes, it does work. You know, the user information, you know, blah, 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 is returned for me. Now, if I change this, and if I say, you know, another user, this is not permitted because I'm not in the HR representative role, and therefore I only have access to my own information. Okay, so enough of the demonstration. Let's go back to okay. So what is it that you should take out of this presentation? I guess is that well, to some extent, I hope I've made some inroad in convincing you that, for the most part, if you look at it right, you can get out of the security programming business, almost. Okay. And the way you would do that with COM+ is to mostly configure access control with COM+ roles, to leverage the Windows NT and the SQL Server facilities, and to just use the few programming idioms that are necessary in order to handle, the sort of various cases that I've shown you to build more elaborate scenarios. To configure authentication, and thereby letting COM+ and Windows NT do, all the more difficult work. And that's it. So if you have questions now, I'd be happy to answer or try to answer them.